We're in section 4.7, scientific notation on page 204. All right, in example 1, we are writing numbers in scientific notation. Basically, here's what that means. Scientific notation is a shorter form of writing the same number. So we're not changing the value of the number, we're just writing it in a shortened way. Because when numbers can be written in scientific notation, it means they're really, really big numbers or they're really, really small numbers. But either way, they're very large numbers as far as digits go. There's a lot of numbers. Okay, so in the first example, it says 120 million, and they want me to write it in scientific notation. Well, the first rule is that my decimal value that I write in scientific notation has to be greater than 1 and less than 10. So if I have 120 million, I need to move my decimal. Everybody agree my decimal is right after the ones place, right?
Yes, Mom.
Well, I need to move my decimal to a place in this number where it gives me a value that's greater than 1 but less than 10. So what if I were to move it here after the 2? Does that give me a number that's within that range?
No.
Greater than 1, less than 10? No, it doesn't. So what about if I moved it here?
Yeah.
0.12. Is that greater than 1? No, it's less than 1. The only place that it can go is between the 1 and the 2. And most of the time, it's going to go between those first two numbers, 1.2. Okay, so that's going to be my decimal value, is 1.2. And I always multiply it by a base of 10, a power of 10, because when I move places, I'm increasing by powers of 10. I go from 1s to 10s to hundreds to thousands to 10,000s. They're powers of 10 that I'm increasing by. So in order to figure out what my exponent's going to be, I have to count from my old decimal place to my new decimal place, how many places did I move my decimal? So I went 1, 2, 3, 4, 5, 6, 7, 8. So it's times 10 to the 8th power. Okay, however many decimal places you move from the old decimal to the new decimal, that's going to be your exponent. All right, now in the second example, now it gives me a very small number. So again, I still need to move my decimal to a place in the number that gives me a number greater than 1 but less than 10. So if I move it here, 0.12, is that within the range? No. The only place I can move it, again, is to the 1.2. Now, I multiply it times 10, and I count 1, 2, 3, 4. But since I'm dealing with a very small number and I'm moving my decimal in the opposite direction, it's going to be a negative exponent. An easy way to remember this is when you're making a very small number into scientific notation, it's a negative exponent. If you're changing a really big number into scientific notation, it's a positive exponent. All right, so now I want you to turn in your books to page 205. I want to do some practice on writing numbers in scientific notation. It's also in your checkpoint. I'm putting it up on the screen, but it's your checkpoint numbers 1 through 4. 4,100. All right, what's my decimal value going to be?
4.1 times.
Go ahead. 4.1
Times 10 to the third.
times 10 to the third power, because again, I have to move my decimal. Everybody agree 4.1 is bigger than 1 and less than 10? All right, now what about the second one?
6.7 times 10 to the negative fifth.
All right, 10 to the negative fifth. Perfect. What about my third one?
3.4 times 10.
Hold on. 3.4 what?
6.
3.46. You have to include all the numbers in the original number. If you drop off your 6, you're changing the value. Okay, so you have to include all the numbers in your decimal times 10 to the what? 7th power. All right, what about my last one? What's my decimal value going to be? 1.45 times 10 to the negative 5th power. All right, anybody get all 4 of those right? Okay, good. Any questions? In example 2, now I'm going the other way. I have a number in scientific notation, and I need to write it in standard form. Here's the most important part about writing a number in standard form. Look at the exponent. If the exponent is positive, you know that you're moving your decimal right and making your number bigger. Okay? If the exponent is negative, you know you're moving your decimal left, making your number much, much smaller. Okay? So that is definitely a key. And then the exponent tells you how many decimal places you expand the number by. Now, notice I said decimal places. I didn't say zeros. 7 doesn't tell me to add 7 zeros. It tells me how many decimal places to expand it by. All right, so here we go. I have 3.2, and the 7 tells me I'm going 7. So I want you to kind of draw these troughs. We go 1, 2, 3, 4, 5, 6, 7. And for every dip, I'm going to fill in a 0. Okay? Now, I know that this might seem tedious, but if you try to do this in your head, those zeros start blending together. Okay? So then I want you to place some commas in here, make them kind of exaggerated, so you can clearly see what your answer is. And then I want a clean answer, 32 million. 32 million you box in as your answer. 1, 2, 3, 4, 5, 6. Okay, 6 zeros. 32 million.
Oh, I thought the 7 was a 2.
Okay, now on the next one, I have 8.69 times 10 to the negative fifth. So I still start with my 8.69, except now since it's negative, I'm making my number smaller and expanding it left. 1, 2, 3, 4, 5. Sorry. 1, 2, 3, 4, 5. And then I fill in my zeros. Now, whenever you write these, I do need a 0 out front. 2, 3, 4. And my 8, 6, 9. Okay? All right, then on my last one, which way am I going to move my decimal?
Right.
To the right. I'm making it bigger. And my exponent's only a 4. I almost have enough decimal places to expand it all the way. I only need to add 1 0 to make 14,730. All right, so writing numbers in standard form, it starts with that exponent. The exponent's positive. I move my decimal right by that many decimal places, whatever the exponent is. If it's negative, I move my decimal left, and then I write my number in standard form. All right, now I want you to do a couple practice ones. Let's come over here to this one right here. Okay, so I want you to write these 4 in standard form. And there are also numbers 5 through 8 on page 205 if you want to look in your books. What's the answer to the first one?
71,000.
All right, very good. What's the answer to the second one? 2 zeros. 2 zeros. All right, 0.00193. All right, what about the third one?
0.000003641.
Very good, 5 zeros. All right, and now I did fix it. Just give me a sec. I went back and fixed it. Okay, and then my last one's 559 million. 559 million. Who got all 4 of those? 6 zeros behind the 559. Okay, awesome, guys. Good job. All right, now in example 3, we're comparing numbers in scientific notation. The first thing we want to look for is, let's say I had 2.49 times 10 to the third, and I'm comparing it to 3.42 times 10 to the fifth. All right, now my rule says that the first thing I look for is my exponent, my power. If my powers are different, it's as simple as which one is bigger, and that's my bigger number, okay? Now, if my exponents are the same, let's say I've got an exponent, let me erase this. I have an exponent now of 2 and 2. So now my exponents are the same. Then I look at my decimals, and I see which one is bigger and which decimal is bigger. 3.42, okay? So I look at my exponent first. If they're different, the larger exponent's bigger. If they're the same, I look at my decimal. Now, what if I had negatives? What if I had, let's say, 4.52 times 10 to the negative fourth compared to 5.41 times 10 to the negative sixth? Okay? Wait. What sign belongs in the blank, though? Is negative to the negative fourth, is it greater than or less than negative 6?
Greater.
It is greater than, because remember, with negative numbers, the farther I get from 0, the lesser the value. So this one is greater than. And then the same rule applies if my exponents are the same, then I look at my decimal value. And so let's say this one is negative 6, 2. All right, now I look at my decimals, and which one is smaller?
4.5.
Okay, so then it would be less than. All right, so this is how it's going to look on your homework tonight. Hold your questions for just a second. Here's how it's going to look on your homework tonight. You're going to have numbers that are in scientific notation and numbers that are in standard form. You need to change all the numbers to scientific notation first. So 3,800,000, we're just going to write directly above it 3.8 times 10 to the 6th power. And now I can compare them. I have a 6, and a 5. So which one's the smallest? 4.2 times 10 to the 5th. That was easy. 4.2 times 10 to the 5th power. But now my 6's, since my 6's are the same, I have to look at the decimal values. Which one's the next smallest? 3.8 or 3.9? 3.8 is smaller than 3.9. So I write it in the original form, 3,800,000. Make sure you're writing your answers in the original format. And then 3.9 times 10 to the 6th. All right? Any questions? Okay, a little bit more classwork. I want to do these two. So we need to change 49,000 to scientific notation, 4.9 times 10 to the 4th. Now, since I have two 10 to the 4ths, I need to look at my decimals and which one is smaller. 3.3 times 10 to the 4th. And then 49,000. And then 2.4 times 10 to the 5th. On the last one, 1.7 times 10 to the negative 4th. Well, I have a tie for the smallest, so now I need to look at my decimals. And is 1.7 smaller or 1.9? 1.7, so 0.00017, then 1.9 times 10 to the negative 4th, then 2.8 times 10 to the negative 3rd. Anybody get both of those right? Anybody get both?
No.
Anybody get one of them right? Just miss the other one? Okay, do you see where you went wrong? Do you have any questions? Okay, in example 4, now I'm multiplying numbers in scientific notation. All right, so I'm multiplying, in this example, 1.5 times 10 to the negative 4th power times 5 times 10 to the 3rd power. All right, now commutative property of multiplication says that I can multiply in any order. I want to multiply my numbers together first. What's 1.5 times 5? It's going to be 7.5. 7.5 times 10. Can I use my product of powers property? 10 to the negative 4th plus 3 is going to give me what? What's negative 4 plus 3? 10 to the negative 1. Okay? So whenever I'm multiplying numbers in scientific notation, I can apply my product of powers property to the ones that have a base of 10. All right, so let's do another one. What if you had 6 times 10 to the 7th times 9 times 10 to the 5th? Okay, go ahead and solve this the same way. All right, so 6 times 9 is 54 times 10 to the 12th power. Well, here's the problem. This is not in scientific notation. Why not? Because 54 is too big, okay? So, if I need to write this as 5.4, basically I've moved my decimal place one more. I've moved my decimal one more, so I need to add that 1 up here to 10 to the 12th times 10 to the 13th. Do you see that? I moved my decimal place one more place, so I need to add 1 more to my exponent. 5.4 times 10 to the 13th. You might have one of those. Actually, you do. Wait, hold on. Yes, you have one of those on your homework tonight. So number 46 is going to look like that one.
Is that only
Just a little hint.
Is that only one the left numbers?
Okay. Hold on one sec. If you understand that, that's everything you need to know for 4.7, the last section of chapter 4.